This video is just a quick review of univariate data aimed at General Maths B students studying for the Semester 1 exam. So what we're going to look at with univariate data is how we classify data, how we display that data, then how we describe those distributions or displays that we've made, a quick look at summary statistics, and brief look at box plots. So firstly here we're looking at types of data. So we know that when we collect data we need to be able to describe it as either categorical or numerical. So categorical data is basically when you ask someone a question and they're giving you a worded response. So for example, if I was to survey Year 7 students and ask them what their favourite AFL team is, that would be categorical data. The way we display categorical data is either in frequency tables, bar charts, or dot plots. And we'll have a quick look at some examples of that on the next slide. Numerical data is when we ask someone a question and they give us a numerical response or a number value. There are two main types of numerical data. One is discrete data. So for instance, if I was to ask the Year 7 students to tell me how many siblings they have in their family, they would be counting the number of siblings, therefore that would be discrete numerical data. Continuous data is something that is measured. So if I was to measure the heights of all of those Year 7 students, I would be measuring that. So the height data would be continuous numerical data. Now numerical data is shown in frequency tables again, or in histograms, stem plots, box plots, or dot plots. And again, we'll have a look at some examples of those on the next few slides. So here we have some categorical data over on our right-hand side. And that's displayed as a dot plot there. So from a frequency table, or if we were to convert that into a bar chart or a dot plot, we can see which is the most popular category. And if we look here, we've got a frequency table which is showing the frequency of a response to a question, whether it's true or false. Then we've got the percentage frequency. And finally in the third column we've got the cumulative frequency. So that's just adding up the frequency as we go along down the table. On the right there we can see that's now been made into a bar chart. Now the key thing to note in a bar chart is that the columns don't actually touch. So we can see that they're quite separate categories, true, false and unsure. The key thing we're describing there from a bar chart or any categorical data is the mode, the most frequent. So we can see from that particular set of data that the most frequent response was true. And that can be seen from either the bar chart or from the frequency table. When we start looking at displaying numerical data, as we said, a frequency table can be used as well, and the way we set it up is the same as we would for a categorical set of data. We also, if we have particularly large sets of data or we're using continuous numerical data, we want to group our data set, and we'll look at some examples of that on the next slide. From our frequency tables, the most common way we display our numerical data is with histograms. So we'll have a look now at how we display the difference between discrete and or continuous data. So on the left-hand side here, we've got some discrete data. We're just counting the number of visits someone has made to a particular landmark. And so we can see there were 6 people who made 0 visits, there were 7 people who made 1 visit, and so on down the table. Below that we can see our histogram, and it's actually visiting a cinema during a month. So we can see here the difference between our histogram and our bar chart. Here our columns touch. Now you'll also note on the left hand side histogram that the values 0, 1, 2, 3 and 4 are sitting underneath the column, in the middle of the column. And that's because we have discrete data here, or whole number values. When we compare that to the histogram and the frequency table on the right, this data has been grouped. It's still discrete data, we're still counting it. However, the group or the data itself is quite large, going from 5 up to 29. So instead of writing each one of those as a single line in a frequency table or a single column in the histogram, we actually group the data in fives. So we can see there was one person who took between 5 and 9 passengers. There was, in the group 20 to 24 passengers, we have a frequency of 4. The other key thing to note is on the histogram now, those numbers or the start values of each of those class intervals is given at the start of each of the columns. So we can see the 5, 10, 15, 20 are now at the beginning of the columns in the histogram. So how do we describe our histograms? 4 key things: shape, center, spread, outliers. Shape refers to whether the data was symmetrical or skewed. Center talks about where the middle of the data was, and we use the median value to represent that. Spread is talking about the range, and range is given by our maximum value minus our minimum value. And finally, outliers, is there any particular data point that sits well outside the rest of our data? So if we have a look here, we've got a stem plot here, or a stem and leaf plot, as is also known. We can only use this for discrete data, but let's firstly have a look at how we would describe that. Our stem plot is much like a histogram, it's just turned on its side. So we can see there we've got a peak in the row that's labelled 18. And so we can see our data's trailing off towards the smaller numbers or the negative direction. So that would be negatively skewed data. There doesn't appear to be any data that's sitting outside the normal range, so we have no outliers or no apparent outliers. Our range is going from a maximum of 202 down to a minimum of 154, so we have a total range of 48. And our median value is in the middle. Now we would have to count that up and split our data in half. So we have a total of 30 data values here. And so if we just work our way from the minimum here at 154, the middle is going to be between the 15th and 16th data value. So if we count our way along, we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the median value is actually going to be here between the two 9s. Now they're the same value, so that means our median is at 179. The key thing with a stem plot also to remember is that you also always need a key. So it's possible that without that key there telling us that the 15/4 equals 154, it could mean 15.4, it could mean 1.54, it could mean 15,400. So it is important to always put a key if you're constructing a stem plot. If we look now quickly at some summary statistics, so these are the values that you're getting from your calculator. So if you've got a set of data that you've put into your lists and spreadsheets and asked it to calculate the one variable statistics, remember what we're looking for with the mean, that is actually the value that's given as x with a line on top, or x bar. Our standard deviation is given as SX, and that measures how far on average the data is away from that mean or central point. We want to use those two values whenever we identify our data as being symmetrical. If we decide that our data is skewed or has outliers, then the best way to measure that centre and spread is actually by using the median, which we've just looked at, and the interquartile range. And again, those values can be found on your calculator in that one variable statistics. When we're describing either symmetrical or skewed data, range is appropriate for both types of data. It's just important when you've got symmetrical, mean and standard deviation are the preferred version. Finally, a quick look at box plots. So we use our 5-number summary from that one variable statistics page to construct our box plots. We should always do a calculation to identify any outliers. Now our calculator will actually draw the box plot automatically with outliers and draw your whiskers out to the appropriate point, but it's worth revisiting how you do that. So if in the case of this we had an outlier and the outlier was out here at say 11, we would only draw our whisker here out to the maximum value. So we might find that the boundary or fence at the upper end is at 9.9, but we don't draw our whisker all the way out to there. We stop it at the last known data value inside the fence, and then our outlier is just drawn as a dot on the outside of that fence. If there are 2 outliers, there would be 2 points on the outside of the fence. And again, your calculator gives you that information so that you can check that what you've drawn is actually what should be constructed as well. Remember, a key thing with a box plot, it is showing the quartiles. So each of those sections is worth 25% each. That is, this end whisker is worth 25%. Half of the box is 25. The second half of the box, 25. The final whisker, 25. Which means the actual interquartile range here is giving you 50% of the data. So that's a nice little thing to remember, because quite often that's a trick question that examiners like to put into an exam.